All right, how's everybody doing? All right. So we'll get started in a couple minutes. Does anyone have any questions while we're here a couple minutes early that I can help with? Well, this is a nice day to be working at home, right? We're going to be stuck at home. Might as well be when we're getting snow this week.
Yeah, I love watching it fall. I'm just like programming and like the white hard background with the white snow. Oh, it's so nice.
Yeah, now I have some shoveling to look forward to as well. So that'll get me out of the house. So as people are coming in, the plan is to work with the same R markdown file that we were working with last time. So I have a PDF version of it open at the moment, but I'll be working in our markdown. It's worksheet 02. So if anyone does not have that, let me know. I can drop it in the chat. Are people able, like when I drop files into the chat, are you guys able to open them?
Yes.
Yeah, we can.
Okay, yeah, there's all sorts of weird settings in Zoom, so I don't know how it's set up, but I think it seems to be working. But if you're having trouble getting that, I can email it to you, but they are also posted up in Canvas.
Do you know approximately what line of code in the R Markdown sheet that we're currently at?
Yeah, so I'll open that up in a second, but we basically did the density plot was the very last thing that we did. So we did not do the index plot or the QQ plot. So that's where we are. So I'll open it up in a second, the actual markdown file, because you may need to go back and run a bunch of the cells that we ran up to this point in order to get things running smoothly. So you might have to reload that PIMA data set and so on. Awesome. Okay, well, welcome everybody to hopefully our last remote class for the semester. So we will be back in the math department on Tuesday for class, barring any crazy weather, I suppose. So it was nice hanging out with you guys remotely, but I'm looking forward to being in the classroom next week. I think this actually worked out well because the weather's crappy, so here we are safe at home, and we'll be working with R again, and it's actually kind of convenient if you've got your computer handy and can work in Markdown. So I'll just say, like, when we're back in the classroom, there will be days where R won't be as central to what we're doing, and there will be days when it's going to be really central. So I'll try and give you a heads up as far as like, hey, you might want to bring a laptop if you have one on this day, because we'll be doing a lot of stuff on R. But I'll try and give you some warning for that. On Tuesday, it won't be a heavy R day. So if you don't have a laptop with you in class, it'll be fine. Any questions before we get started for today? Someone mentioned that the video that I posted of our first class was like cut off in a weird spot. And I think that's because I was sharing my R window as opposed to like my entire screen. And I think it got confused where to cut things off. So I was able to recenter things and upload a new version. So there's the original version and there's a newer version up there if you want to see that. But if you are having any issues with the recordings, just let me know and I can try and fix it if anything's off. I noticed that some of them are clearer than others. I have no idea why. Some of them were like in high definition versus standard definition. I'll just let YouTube do its thing. But if you have any trouble seeing any of that information, just let me know. Okay, so I will open up R. And again, I am working with that file, this worksheet, data exploration. And maybe I'll just put this full screen so it'll think maybe that will edit it better. Okay. Is this large enough for everybody to see the font? Okay. Just please let me know if you want things bigger.
Can we go one larger, please?
We can definitely go one larger, I think. Oh, I'm enlarging my chat. It's the wrong window active. Let's do it on this one. Okay, how's that?
That's great.
Okay. Okay, so you may have kind of a fresh kind of looking window. So this again is this worksheet 02. If you try and knit the whole thing again, you won't get any of the R code running because I put this thing in the front that says don't evaluate any of the R code in here. So my intention is that we're running things as we move along. And then when we've got everything set up in the end, we can delete this block of code and then render it straight to whatever file format you like. So if you close this and have been working on other things, I need to catch up and rerun all of this stuff. So things that you would need to do. So this is lines 78-ish in the block, right? We would need to upload the faraway package because that's where our data set is. So that's all this line of code is doing. Not running any of this stuff won't get in the way. We did clean this up and we want to make sure that we do that step. Since we had some issues with seemingly missing data that was coded as zeros. So if you don't run this, your data set will be a little bit different. So just keep that in mind. So I'm going to run this. That should clean up all of those zeros. And then we had an issue with the variable test. That was a categorical. Either it was coded as a 0 or a 1, depending on whether the individual tested for positive for diabetes or not. And so this line of code, first of all, took those zeros and ones and made them categorical into groups. And then we wanted to make these things more descriptive rather than zeros and ones. We can call them negative, positive, depending on the test result. And that looks like that. So I think that's the main stuff you would want to do is just load that data and then do the cleaning process that we did last time. And then you should be good to go with what we're going to do today. So yeah, we made some histogram last time using kind of the base plot system over here. And if you ever are doing this and you're like, this is a really big plot and I don't want to see it, you can kind of delete it, hitting the X over here, or you can collapse it if you don't want to see it. Okay, and then we just kind of made a slightly nicer plot, and I think this is exactly where we ended things with this lovely sea green density plot. Any questions about what anything that we did up to this point? Okay, so yeah, so then let's kind of talk about a couple of other plots. So right now we're doing what we would call like univariate plots because we're just looking at one variable as opposed to comparing two or more variables. So this line of code, maybe we got to this part, I can't quite remember, but this is kind of doing two things in once. It's sorting all of the PIMA data by the blood pressure, and then it's going to plot it. So, right, usually with plots, there's two axes, or at least with if you're using the plot function in R, it's assuming like XY sort of plots. And we've only imported one data point here. So it's reading pairs here as like X is equal to 1 would mean like this is the smallest data point, and then the Y value would be like what is the actual value in the data set, right? And then the next point would be X coordinate 2, meaning the second smallest value in our data set, and then the Y value is the value. So the x-axis is not all that interesting when we do a plot like this. It's just counting up all of the values, and there were like 600 and some odd values in the data set. But it's probably more the y-axis, which is measuring this quantitative variable over here. Does anyone see any interesting trends in, like, why would a plot like this be useful? What sort of information are we getting out of this plot?
How close to normal?
So we might see some sort of normal distribution in here. And we'll take a look at a quantile plot, which will get at that idea as well. What is it about this plot that makes you think that it might be normal? Not just Samantha, but for anybody, but feel free, Samantha, to keep on with your train of thought. But I would agree that this looks a bit normal.
Because there's like just that steady line of, it looks like we have a range from about like maybe 50 blood pressure diastolic up to like 90. And then that's like where the chunk of all of our data is. I think that might be a good sign. It's like, okay, we're going to have a lot of our data in that range instead of it just being all over the place. Like,
yeah, so we kind of see like there's a big cluster of data in here where, and I think can you see like this annotation? This is Zoom annotation here, where, out here at the ends, right, things are looking a little bit more sparse. And so how is it that we're like seeing sparseness versus like dense data in a plot like this?
Looks like few circles or a ton of overlapping circles.
Yeah, so it's actually like when Y goes up quickly, like diastolic blood pressure goes up quickly when we hardly change X at all. This means there are not a lot of values over here, right? When you see something like this in the plot, this is telling me that there were a number of values, like from here over to here, and you can kind of like, we can estimate that distance. I am ballparking this really badly, but let's just say like that distance is about 50. So you can see there's about 50 values in this data set that had blood pressure that was about 70. I'll approximate that over here. Right, so when we have like multiple values that are the same, that actually appears flat, right? The Y is not going up. All of the Y values are staying the same. Any other observations about this plot? Yeah, Joe.
Some of those people should really consider going to the hospital.
Yeah. Yes, I think we talked about this a bit last time, that maybe our initial cutoff is a bit too, we just chopped off the zeros, and maybe this person over here was not like a 30, but maybe they were 130 or something like that. Not that that's also kind of troubling, but yeah, we have outliers on the end. And this might be a situation where you're more interested in the outliers as opposed to like the typical person in the data set. Any other, yeah, thank you, Joe. And any other observations? So it seems to me that they're also not measuring this perfectly accurately, because it would be odd that like 50 people had the same precise blood pressure, right? And it seems like we have some steps here, and that's because they were rounding this to even numbers, right? So people had either a blood pressure of 60 or of 62, but nobody in this data set has a blood pressure of 61. So we can pick up on some of these data entry things by looking at a plot like this. Okay, I want to not annotate anymore. Okay. Any other observations or questions about that? Let me get rid of this stuff.
Yes, I had a quick question
Yeah.
about if we didn't, sorry, if the data wasn't collected with even numbers, would the line be more like less step,
Yeah.
with less visible steps? Okay.
Yep. That's right.
Would it look more like a straight line, or would the steps just be less high?
It would look less jumpy. You're right. It might
Okay.
look like a little bit more continuous. Yeah. So yeah, and the odds would be that like you wouldn't get so many people with the same exact blood pressure if they were measuring this a little bit more accurately. But yeah, the big feature here is this big step. And that's because we're hopping over these odd numbers in the data set. So it would look maybe like more continuous as opposed to steppy.
Thank you.
Yep. Okay, so then I will leave that plot as alone, and we'll kind of think about the next one. So it was mentioned that this data that we had over here, and we also plotted over here, you can see from here, like, seems like it might be reasonable to use a normal distribution to approximate this. It's kind of bell-shaped. And so if you're kind of curious about what sort of theoretical distribution might match my empirical data, that's where a QQ plot comes in. So it'll kind of plot two distributions together so that you can compare them. And usually when we're doing statistics, we have some underlying assumptions that data is normally distributed or something like this. So more often than not, we're really interested in saying, does our data seem to follow a normal distribution? And that's what's called a quantile plot. We're comparing quantiles of one data set to quantiles of another data set. And the most common one to use is a normal one. So we would use like a normal QQ plot. And so for a normal distribution, the command is QQ norm, and you input the variable that you're working with. And this option over here is going to add a line to that QQ plot. That'll kind of just help be a reference line. So I'm going to run this code. And here's what this QQ plot looks like. It's kind of similar to that that indexed plot that we gave, and where we can kind of still see the steppiness in this data. And the sparseness that we have in certain parts, this line that we've drawn in the middle. So what you're kind of looking at on the bottom, these are complicated plots, is you're basically looking at z-scores for like a standard normal distribution. And what we can see is, okay, like here is, if our data, our empirical data was normally distributed, then a z-score of -3 should be like about a blood pressure of 39. But what we're seeing over here is that a blood pressure of 39 actually in our data set is not as far away from the mean as it should be. So these are tricky. And so like at its simplest, if all of my dots fall on the line, then that's a good indication that my data is normal. If my dots are not falling on the line, then that's an indication that things are not so normal. So what I can kind of see inside here is that in the middle, things look pretty normal. But at the tails, not so much, right? We're kind of falling off of the distribution over here, as well as on the upper end over here. So the way that you can kind of read these, it's similar to these indexed plots, and that is like when you have flat data, when your dots are flat, that means you actually have really dense data in that area because you've got a whole bunch of data squeezed in. And when your dots are kind of going up more steeply, like they are over here, this is an indication that your data is more sparse. So kind of what we're seeing over here is that our data looks a little bit more sparse in the tails than it would be in a normal distribution. So these are something you may or may not have much experience looking at, but they're called QQ plots, and you might want to check some of them out. And let me just share one other thing. Here it is. Just to kind of illustrate this idea of QQ plots. Here's kind of a worksheet I've done in a different class. But like up top, you can see the histograms for the data. And on the bottom, we've got different QQ plots. We can kind of try and match this up. So what do you think would be, which of these distributions do you think matches, for example, B down here?
One,
Why'd you say 1?
because it's the most normal distribution.
That's right. So that seems like a good match over there. So when things are lining up on this line, great. Our data should be approximately normally distributed. Does anyone have a suggestion for which of the histograms above would match A?
Is it 3?
That's right. This one would be 3. What was the rationale there?
It's starting on the increase, so it's kind of like ramping up to the peak. It's kind of how I see it.
Yeah, so like this stuff over here means we don't have a lot of values in the lower tail. In fact, we have less values in the left tail than a normal distribution would have. And that's kind of what we're seeing, is that this distribution has less stuff than what a normal distribution should have. And that's why it's flatter, or excuse me, steeper over here. And this part over here is telling me, right, we have a whole bunch of values in our data set that were between -2 and 0. And that's all of these values over here that we're seeing stacked up. So this data in histogram 3, we would say is skewed to the left. And just remember that in statistics, we describe the skewness in the direction of the tail, as opposed to like where most of the data sits. So we've got a tail over here, so this is skewed to the left. So that's how you can identify skewness in a QQ plot, would be looking at this. Which do you think would match histogram 2, which is skewed in the other direction? Now we've got a tail to the right over here.
E.
Yeah, so this one would match up with that one. And then what is essentially like a uniform distribution in 4 is mapping this one. So what this is saying over here, right? Remember that when it's flat, that means you have a lot of values. So what this is saying is whatever the underlying distribution is in C, it's got way more stuff over here than a normal distribution should have. And it has way more stuff over here than a normal distribution should have. But that's kind of a side detour. They don't have this in the text, but I think it's worth kind of talking about when we're looking at plots for univariate data. This is kind of like a univariate plot, but at the same time, we're comparing it to a normal distribution. Any questions? Okay, then I will go back into R. Okay. Okay, so next let's take a look at what we'll call like bivariate plots. And so this means we're comparing two variables. So the type of plot that's going to be created is going to depend on the type of variables that you're inputting in here. So what we're kind of doing in this line of code is let's load the data. And then what we're going to do is we're going to compare the diabetes to diastolic. And let me just double check what these variables were again. Yeah, so we had blood pressure and then diabetes is a diabetes pedigree function. I have no idea what that is, to be honest. Is anybody here versed in that? Yeah. Let's Google it because I am curious. Like what might be good to know.
And she's definitely said that word before.
What's that?
My girlfriend's a nurse and she has definitely said that word before.
It's a function which scores the likelihood of diabetes based on family history.
Yeah, thank you. Yeah, I'm just catching up with that as well. Yeah, so based on a couple of different factors, they are scoring pretty much your risk at getting diabetes is what I can gather from this. It is pretty common with a lot of different diseases. And in fact, someone was doing a whole bunch of regression to come up with that function. They're trying to see what things are correlated with an increased risk in diabetes. And so what I'm mainly interested in here is like the higher the value, the more at risk you are. Okay, certainly not my specialty. Okay, I did something bad. Let me get my screen back. Okay, so let's take a look at what we get when we plot this. So we get a scatter plot here where we've got blood pressure on the x-axis and we are plotting the diabetes pedigree function on the vertical axis. So one thing that's important to note here is it reads y first and then it does x, right? And if you want to flip it the other way, then you can flip it the other way. Changing the order around here would just change what's on x and what's on y. And you know, in the world of statistics, like when we're thinking about functions, we typically think of like we describe our pairs as x comma y. When it comes to doing some regression, we typically think about y as being the kind of dependent variable first, and then x being kind of the independent variable. Like diabetes depends on your diastolic is what this is kind of saying here. So it knows by default that these are both numerical variables. So therefore, I'm going to create axes that both have numerical values on it. So yeah, so looking at this plot, do you see any patterns as far as blood pressure relating to this diabetes pedigree function?
I don't really see a strong correlation because it looks like for values that are higher on the y-axis, they're roughly in the normal range for diastolic blood pressure. So it isn't like the higher your diastolic blood pressure, the more likely you are to develop diabetes, if I'm reading this the right way.
Yeah, so so here were, you know, people that had higher scores. There's not that many people up here, but if you kind of look at people that had higher scores on this diabetes pedigree function, you know, what you might want to see is like, okay, are all of these people, do they all have like something similar about their blood pressure? And it seems like we've got people in here that have low blood pressure. Most likely we have people that have like a healthy blood pressure, and then we have some people that are too high. And I don't think that changes too much if we were to look at kind of like the next segment down below. I guess maybe, you know, we don't have any low outliers, but this looks like a pretty big outlier over here. That might be in error, but this does also pop out some notion of like what outliers might be and what some other data entry issues might be. We definitely can still see the steppiness in, you know, how blood pressure was measured here. So
Yeah, there are some pretty clear gaps between all of the values down near the diastolic axis.
yeah, we've got some jumps. But like what you can kind of see here is like, okay, here's someone that had like roughly a 70 blood pressure. And you can see that these people have everything from like a very low score all the way up to a very high score. And it's not all that different for someone that has low blood pressure over here. They also had people that were lower, though they didn't quite have as high on the scale. Yeah, and so it kind of looks like a cloud here of data. It's a little bit hard to find the pattern in here. I mean, what people might be thinking about are, you know, I'm trying to think as I move to the right, as one of these variables goes up, do I see a trend in the other variable? Does it tend to go up or does it go down, or is it bouncing all around? And it seems like here, as we move to the right, as we increase one of these variables, diabetes just kind of popping all around. Any other comments people want to add about this? Okay, so we can do the same sort of thing, but now I'm going to change this second variable from diastolic to their test, right? And again, this was a categorical variable. Either the test came back positive or the test came back negative. And when we want to compare values, quantitative values of two different quantities, the default here is that it's creating side-by-side box plots, which is a good default. That's a really convenient way of comparing these two different groups. And so here, I think you would hope for some correlation because this diabetes pedigree function is assessing an individual's risk for developing diabetes. And that should be consistent with the test result of the screening test. For those that are not as familiar with these box plots, the way they go is, right, we've got third quartile over here. That would be the third quartile. This is trying to be a Q3. I'm writing with my mouse now. Sorry. Right, we have the first quartile over here is indicated with this lower bar. Oh, what am I doing? This is not right at all, right? Let me clear all that away. Sorry, where is the first quartile going to go? You guys can correct me.
It's the bottom of the box.
That's right, thank you. The first quartile is in the bottom of the box. That's here, and the third quartile would be over here. Sorry about that. And this distance between, I'm just putting out a lot of terms there, and you're welcome to stop me and say, hey, what does this mean? Please don't feel bad asking any questions at all. I'm sure others in the class might appreciate that. But this distance from between the quartiles is what we call the interquartile range. So we sometimes shorthand that with IQR. That's just a different way of measuring spread in a data set. And the line in the middle is telling us the median. So with box plots, we're generally measuring center with the median as opposed to the mean. And then these things, these arms over here, we can call them like the ceiling and the floor for determining what are the cutoffs for outliers. So what I can see in both of these plots is neither group had any outliers as far as low score on the diabetes pedigree function, but we can see what it means to have a large score on that here, right? It seems like anything that's kind of above 0.6 seems to be pretty extreme. So basically, when you're looking at a box plot, a good way to think about it is you've got 25% of your data here, 25% of your data here. So this is telling me where the middle 50% of the data values are. And then you've got the remaining 25% down here. And the other 25% are over here. So it's dividing the data into 4 equal portions in terms of how many data points fall in those intervals. So does anybody see anything interesting looking at this plot, comparing these two box plots?
We're seeing positive has higher scale on the diabetes thing,
Yeah,
but
so
still
this,
not super significant.
yeah, this box plot seems to be a little bit higher. And certainly like looking at the median of this box plot, which is over here, you know, it's higher than the median and the box plot over here. So the positive group has a higher median than the negative group does, which is what you would probably expect, that the group that tested positive should have, you know, generally speaking, more people that scored higher up on this pedigree function. What else can we see from these box plots? Like, how would you describe the shape of this data in terms of, is it symmetric, skewed to the left, going to be skewed to the right?
Looks skewed to the right.
Yeah, that's right. So again, we described that skewness with like the direction of the tails. And so with box plots, right, tails are kind of these dots. And so I can see that most of the values are squeezed over here between 0 and 0.5, and then it gets more sparsely distributed after that. So both of these distributions have generally the same sort of shape. They're both skewed to the right, And the upper scale is not all that different, but it's kind of like how the middle 50% are being distributed is where the big difference is here.
This might be going on like, I don't know. I'd have to like fully understand what it means, the whole pedigree function. But wouldn't, like, if diabetes like ran, I guess, in a family or whatever, wouldn't the positive be more skewed to the left, I guess, or wouldn't it at least be higher? Doesn't this kind of imply that diabetes doesn't really run in a family?
So if we were to plot these, and we certainly could plot them, on a histogram separately, but this is kind of saying that this data, I don't know, I'm messing up the shape here, but it kind of looks something like this, I would suspect. Same for the others, in that we kind of have like, maybe here's the lower 25%, here's the next 25%, here's the next 25%, and then there's the rest of this stuff. So we're kind of doing the equivalent of saying, here's first quartile, median, second quartile. And I think if you were to compare these two, like in terms of their histograms, if you like that, they kind of have the same general shape, just this one has more stuff clustered over here. So it's going to kind of peak up higher. And then we still do have a couple of things out here. So yeah, there are a couple of people that tested negative that had high scores. And it's good to note that, like, hey, these people might have been misdiagnosed or something might have happened. But overall, the group that tested positive, generally speaking, like the general trend is they are getting higher scores on this pedigree function.
Slightly. Yeah.
Slightly, yeah. But at the same time, I don't know enough about this pedigree function to know like how drastic is the difference between a half and one. Maybe this is on some like weird log scale, and that like the difference from 1/2 to 1 is like not as drastic as like a difference from 1 to 1.5 and so on. Yeah. Definitely I am handicapped by like not knowing enough about the context of this function. Yeah. But that's okay. I'm just trying to make a point that I don't think that we all need to be experts in all of the data that we're working with, but knowing what sorts of questions to ask the expert is good to know. Any other comments?
Sort of going off of that, is there a way that we could find out more information on this specific data set? I know that when you look under help, it has a description and it tells you a short blurb about what each of the variables means. But is there anywhere you can go associated with this data set where you could see more in-depth information?
I would start with, I would start with doing the help thing that we did, because who knows what that brings up. And so it brings up this. And then I would see, okay, this came from the National Institute of Digestive and Kidney Diseases. Let me Google that. And I would start to kind of track down that. But at least this tells us like the agency where this data came from. And I'm guessing they collected data on lots of different population groups. This one happens to be for the Pima Indians. Yeah.
Thanks.
Okay. So the next thing I want to kind of talk about is, yeah, how could we kind of generate multiple plots at one time and kind of display them all at once. And so this is where this par function comes from. So this is just setting up parameters for how the plots are going to be displayed. And we just indicate how many columns and rows we have. First, we indicate the number of rows, and then we indicate the number of columns, like the usual way of describing things in matrices. So here we're going to set up one row that has two different plots. The first plot is going to be the scatter plot that we saw. The next plot is going to be the side-by-side box plot that we saw. And this just gives us another way of formatting the output. That did condense the axes, and that made the scatter plot kind of a little bit less accurate on that scale. And it's going to save that setting that you use for any other plots that you do later on down the line. So if you want to set it back to just give me one plot, then you can add this back at the end. So this kind of created this template for showing two plots. And then we inputted the two plots, and now we're just kind of resetting the system back so that it just displays one plot at a time. Okay, so we'll be plotting things mainly in base system, but there is a really nice package of plotting called ggplot. ggplot stands for the grammar of graphics. And so with data science, they kind of have broken down different components of plots in terms of like what are useful things that go into plots. And it's kind of, it's the data, it's what kind of plot are we going to use, and then it's what are we plotting on what axis and how are we plotting it. So if you want to play around with this and you haven't installed ggplot2, then you would have to do that. I won't do it, but you would want to do like install packages. And then hit ggplot2. And then when you want to use it, you would load it in with the library ggplot2. And it's really robust way of creating plots. And if you're kind of curious about getting some information from it, one way is if you remember where we got kind of the cheat sheet for working in R Markdown, if you go up to the help menu for RStudio, I don't know, can you guys see? I don't know what you can see. I don't, probably can't see that. Oh, you can. All right. Then you can go over, and there's all sorts of cheat sheets you can see in here. And so if you're really curious about working with, I think there's a ggplot2 one in here. There is. So there's one that's data visualization with ggplot2. And if you open this up, sorry, my screen's got screwed up because I'm downloading something. I'll show you what it looks like. It downloads a little PDF that might be useful to have someplace. That just has way more information that you probably care to know about ggplot, but they try to organize this in a nice way. So there's tons of documentation out there. You can get like a PDF. There's a full-on book at Auraria Library in ggplot, the creators of ggplot, that you can download from the library to PDF if you're kind of really curious about getting into the details of this. But I'll just kind of give us a little peek at this, how it works. So the first thing you'd want to do is load the library so that we can use the commands. And let me just run this code and we can kind of describe what's happening. So here I have, yeah, okay, whatever. So here it created a histogram for the blood pressure similar to what we had before. And maybe you think this doesn't look as nice as the base graphics, but what's nice about this is that you can customize it. You can with the base graphics as well. But what goes into ggplot, it really needs three things, which what is the data, so that we kind of input first in ggplot. So that's what we're calling the object. And so maybe this line of code here is doing two things, but I'll just write it out like this. So kind of, we don't want a space there. Right, the first thing that we're doing is loading the data. So I kind of realize that if I'm going to be creating a lot of plots with this data set Pima using ggplot, I can save myself 4 or 5 characters if I do this instead. Okay, just making things minimally easier for us, but you don't have to do that. But we can see that this is first loading the data. That's all that's going on in that step. Then we're telling the system what type of histogram do we want. And that's what's called the geometry object. It might be a density plot. It might be a box plot, right? We can do all sorts of things in ggplot. And then we input what's called an aesthetic. So it's going to create this plot, and it wants to know, what am I plotting on each of the axes? And we just need to tell it. So in this case, it's a univariate plot. So there's just one aesthetic, which is the blood pressure diastolic that we're going to map on the x-axis. And that's what this plot had below. And there are different ways that you could do it. If you've been working in ggplot as well, this line down here would create the same exact thing. Some people like to input the aesthetic at the, they first enter the object, then they indicate what variable we're plotting, and then afterwards they say what plot do we want to use. They'll both generate the same thing. So here are some things to practice. I'll let you guys play around with this for a few minutes, but try and mess around with ggplot and add a little R block down here. So remember, if you want to add an R block, we put in our 3 apostrophes and close it off. But let's try making a density plot for diastolic blood pressure. And if you're not sure how to get a density plot, check out that help document if you downloaded that, or take a guess. So if I am working on this first part here, I want to do ggplot, density plot for blood pressure. All right, so still working with the same data. That's all that first part is saying. What's the geometric object here? Anyone track that down or have know something about ggplot already? I'm gonna share this cheat sheet. Zoom in. So it's kind of useful. It says, all right, here are one variable plots down here. What's the command for creating a density plot?
Geom density.
Yeah, that would be really messed up if they called it like dot plot, right? So ggplot tries to be very intuitive as well. You can see what the names of these plots are, right? They have a QQ plot, it's called QQ. They have a histogram plot, it's called histogram. So it tries to be intuitive. And while we're here, since we are also going to try and create a scatter plot, might be nice to just check out what that looks like. And so for two variables, these are some of the options. And scatter plot is not called scatter here, but it's called point. So I will, using that kind of research, we'll pop back in over here. Notice that like there's also autocomplete in here, which is nice option as well. So I'm going to call this a density plot, and we need to add an aesthetic here. And it's the same aesthetic that we had up here, right? We are going to set X equal to diastolic. So inside the aesthetic, we're just going to say, let's set X equal to that up. That should work. There we go. Okay, so looks the same as the one that we did in the base graphics. And then for this one, we had, right, this one was called point. And now for this aesthetic, we have two. So we can set diastolic on the x-axis, followed by diabetes on the y-axis. And that should do it. Okay, and again, just a different way of presenting the same data in the same sort of plot. But what's nice about ggplot is we can add additional variables to be displayed in this plot other than just X and Y by adding some detail, like the shape of the dot can represent something. Like you can make the shape of the dot represent BMI, and then you can kind of see how BMI fits in the picture. You could have color coded based on whether their test was positive or negative, right? So you can look at more than just two variables on the same data plot. And that's where some of the scaling comes in down here. So if you're kind of curious, down here, we can change the shape of the dot based on whether the person had a positive test or a negative test. And then you could kind of see where were the triangles compared to the circles. If you prefer doing it with colors, right, you could do that with colors. I'll just say you need to be a little bit sensitive with colors. A, you don't know how things are going to be printed out, and B, you don't necessarily want to pick colors that people might have a hard time differentiating. So that's where the shapes might come in handy. But you can do both. So here's one where we're going to plot 4 different variables essentially on this data set. Oh, sorry, we did shape as a test here too. We could do like, you can throw BMI in here. I think that was another variable. And I see, continuous variable cannot be mapped here. Was age one? Ah, pregnant, that's one. Okay, it's reading all these as continuous. Okay, I was trying to get something discrete in there. Anyway, we could change pregnant if we wanted to. I see the problem. Okay, well, we're stuck because all the rest of our variables are continuous. Any questions? Okay, then just the last thing I want to mention about ggplot would be faceting. And so let me just run this code over here. So what this is saying is we're loading up the PIMA data set. We're going to make a scatter plot with blood pressure on the x-axis, the diabetes score on the y-axis, and we're going to facet by the test. And it just creates 2 different scatter plots, or it might create 4 different scatter plots if we had 4, if that variable was had 4 categories. But for each value of test, for each level of test, it creates a different plot. So I think, for example, it'll get mad at me if I try and do something like this. No, it did it. That's really weird. It wouldn't let me use pregnant for the size, but it did read it as a discrete variable here and created a different plot. So now we can kind of compare, like, these are all of the people in the data set that had been pregnant 9 times. And this is what their diabetes versus their blood pressure looked like. This might not be the best way of faceting things, but at least you can see like what happens when you do this. Okay, are there any other questions? I think that I don't want to kind of jump into the probability yet today. We can kind of start that stuff on Tuesday, but this kind of wraps up the R and the kind of data exploration part. Probably some of this was familiar and other parts might not have been. If you had any other burning R questions that I didn't answer, fire away.
If we wanted to print to the plot pane over on the right side, how would we do that instead of printing directly on our RMD file?
Ah, I see. So you could certainly, if you run it from the console, it'll pop out over there. I don't know how to do it within a markdown file, because the default in a markdown, there might be a way to set a global setting in initially. I don't know if you're able to do it. It would be way back at the start of this document. There might be some option that you can add over here that says like print the output over there. But otherwise, if you you can run it from a console, or you can just create a new R script. So like what I typically do when I'm working in these is I'll have like a R script open on the side where I'm just like testing things out. And if it looks good, then I'll plop it inside of this R code. And when you're working in an R script, it will also output the plots on the side. But I suppose there's probably a really nice way of doing that with some initial setting up here. I'm not familiar. You certainly could set a global setting. I think that's called echo, that will not print the output to when you render this file. It'll show you the R code, but it won't show you the output of that R code, even though it's running it so that it's using it in future code blocks, it's still not going to print that output to the file, to the HTML file.
Thank you.
Yep. Okay, then, well, I've got this thing open. If anybody is curious about kind of thinking ahead towards the project. So for the project, you're going to be kind of finding your own data set out there to do some analysis with. And again, the ultimate goal here is to have a nice project that you can present at the data to policy symposium at the end of the semester. And so just a couple of good resources to get data from. I don't know, my background is like dealing with international policy. So I'm very much working with things like the World Bank as like one of the big data repositories. And so if you're not familiar with World Bank, I'll just take you to their website. And show you what their kind of interface looks like. And so they have various different databases in here, and kind of the most frequently used one are these world development indicators.
We can't see the web
Ah,
page.
yeah. Thank you. What were you looking at? Kind of curious.
It was just the R script.
Ah. Okay. Here we go. Okay, so I just Googled World Bank data, came over here to the data bank. And then they have different databases. And again, this was the first one that I was suggesting is probably the one that has most commonly used. And down below, they have, databases that are focused on other more specific issues. So again, this is a good place to go if you're kind of starting to think about your project and what sorts of questions you want to explore. And so they have this whole thing where you can come in and choose which countries do you want to select. I think I have a bit of a lag on my, there should be like a huge list of countries. There we go, that pops up down here, and you can check certain countries if you want. You can just say, give me all of the countries in this database. So it has all of the countries, 217 in here. And then you can select a series, and this is like the variable that you want to take a look at. And so maybe you're interested in, I don't know, energy, right? Just to pick something. And then you can kind of do a search, and then you can see, okay, here are all the different variables that they have on energy. And if you're curious about what it measures, you can click on this, and it's going to tell us something about that variable. But what I want to point out here is what I am interested in, if we're going to import this into R, is this little piece right here. So this is like the name of that variable. So if I wanted to do some sort of analysis on adjusted savings, energy depletion, that sounds really complicated, but we certainly can get access to that data. And it's this little indicator code here that I need to know if I'm going to import this data into R. So my point here was just to kind of show you how you could get those indicators from the World Bank. There's probably other ways that you could do this as well. And you could kind of do your data search here and export it to an Excel file or a CSV file that you then import into R. I just want to point out that there's a nice little widget or nice library in R. Let me share the right screen. So here I can put this up online as well. So there are a couple of good websites that you could kind of check out. One of them is called Our World in Data, and the other is the World Bank. Our World in Data basically takes World Bank data and does some analysis with it. So you can kind of see some of the analysis that they've done. But here's the lines of code where I'm importing this data from the World Bank. So what I needed to do was install this library. So I did like an install packages World Bank stats. That's what that stands for. And so now, once I load that library, I could basically search in the World Bank database in R by entering this command WB data. And I could pick a subset of countries. This means that I want all of the countries and I don't want aggregates. I don't want to see North America aggregated together or South America aggregated together. And then I enter the indicator. So I was working with literacy rates, for example. And then you could enter what year, what range of years you're interested in getting the data. So you're basically doing those three things that the World Bank data set wanted us to enter, like what data do you want to use, what years and what countries. So you could say starting from 1995 and ending in 2015, you could say the most recent 10 years worth of data. This means give me the most recent year, the most recent value that they have. So I just ran the code to get literacy data. I ran the code to get life expectancy data. I ran code to get land area, and I ran code to get GDP per capita. And then I merged them all together. So when I run each of these commands, I'll just show you what happens. Oh, I forgot to load. I need to do this. It's creating like 4 different data sets right now. So it's going online, searching their database, and then it's importing it into R for me. And I've got those that I called area, wealth, health. It missed one. What happened to my education one? It did something weird. There it is. Okay, I don't know why I skipped that one. So it created these separately. And so if I want to kind of just see what it looks like, you know, I've got all the different countries and then I have their different literacy rates. But I would like to have one data set. I would like to compare like, hey, what is the kind of correlation between literacy rates and like the wealth of a country or something like this. I would like to have a data set that has like Aruba, their literacy rate, and their GDP per capita all listed there. So this merge function down here is going to merge all this data together. And we get something like this. So now I can see every country, their most recent literacy rate, life expectancy, land area, GDP per capita. And we'll work with this data set a little bit next week when we do some correlations, right? And I kind of threw some things in here that might have a correlation to GDP per capita and some things that might not, and we can kind of check the analysis with what our intuition might say. Yeah, so I'll just kind of, I just wanted to share that. And if you're kind of familiar with our world in data for any reason, and you want to play around with that, you can play around with their library as well. But I quickly realized that they're just pulling in World Bank data anyway, so I just bypassed them and went right to the World Bank. Okay, so if you are kind of have some ideas about data sets that you're interested in working on with a project, and you're kind of curious about how you can kind of get a nice clean data set to do some analysis with, just let me know. But otherwise, that's it for week 2. So we will pick up with doing some work in probability on Tuesday. I'm looking forward to seeing you. We're regressing with our cameras here. So I think next week I might have been the only person left. So I'm glad that I'll be seeing you in class on Tuesday. And don't forget, you've got homework assignment due next week that's open. And so if you have any questions about that, I've got office hours right now after class, or I'll have them on Monday before we meet again on Tuesday. So my office hours on Monday, I'll be in my office, but I'll also be on Zoom. So you're welcome to come by either way. All right, well, have a nice weekend, everybody.
Thank you.
Yep.
Adam, thanks, you too.
Thank you.